clouds in the sky, and the astronaut is painting a picture in space.
And what are all those little electrodes from the helmet of the astronaut that are going to the rocket?
Yes, he decided that he would also have the astronaut being recorded, just like he was in the study, with we're having his brainwaves recorded.
By isolating his subjects from external stimuli, Dr. Wright can monitor the rhythms of each person's internal biological clock, the time each person naturally needs to sleep, the time each is most awake and alert. The participants of this study aren't in solitary confinement, but everyone working on the unit has been instructed not to give them information about the outside world.
We don't talk anything about the time of day. These individuals don't learn who won the Super Bowl for several weeks afterwards. So yes, we don't keep them abreast of current events.
Because that might give them some clues.
It may give them some clues of what time of day it is, and they're happy to be focused on what they can do during their free time.
Most of us don't have the luxury of sleeping and waking and eating and exercising when our bodies tell us to. But the body does have optimum times for all these activities. We're very rhythmic beings, and the rhythms are synchronized by a collection of nuclei in a region of the brain called the hypothalamus. Scientists call this the human clock. But Dirk-Jan Dijk of Harvard University suggests that clock is not really the most appropriate word for what happens here.
If we look at a clock, we see arms of a clock, but the clock is not really driving the behavior in the room. The essence of the human clock is that indeed it's connected to many, many different functions within our body. I think pacemaker is the better word, but of course it's a little bit more complicated. If we talk about a clock, we often think about, for instance, an alarm clock that gives us one very important signal every day. We could call it the wake-up signal. Turns out that the pacemaker doesn't really give those very sudden type of signals. It's more providing continuous output throughout the entire 24-hour period, more like a process rather than just a clock.
Another reason why clock isn't the most appropriate word is we're not as precise as mechanical clocks. We free range a little. Without this built-in flexibility, we'd be intended for a rather robotic existence. Here's Fred Turek of Northwestern University, who studies our circadian systems.
It's a nice term, circadian. Even circa, you can catch it, means about, round, like a circle, about. Dian is for day. So it means circa, about a day. And it comes from the Latin, and it refers to the 24-hour rhythms which are found in all living organisms, which are generated by an internal biological clock. But the period of this clock is not exactly 24 hours, like the light-dark changes that we experience every day in our environment. It's about 24 hours, or circadian.
In the sleep lab, that's just what happens. The subjects naturally find their own rhythms. Our days vary. They range from 23.4 to 24.8 hours, the average being 24.2. Circadian researchers study the many waveforms from the physiologic rhythms that the human clock sequences.
This internal biological clock is regulating hundreds, if not thousands, of your internal biological rhythms. The sleep-wake cycle is just the easiest one for us to sort of see. But if I were to collect blood from you every hour for 24 hours and then analyze hormone X, hormone Y, or enzyme number 1 or enzyme number 2, they're all varying on a 24-hour basis. Your body is changing internally. I don't want to say every cell of your body, but certainly most of your organs and your tissues are not static. They're not maintaining the same level of activity throughout the day and night. No, they're varying on a 24-hour basis. Some hormones are high during the night, other hormones are high during the day. It's like a symphony. You've got hundreds and hundreds of people playing instruments.